All right, hi guys. So guess what? We are going to talk about application servers. I know you really want to get into that, so let's do it. Application servers are a type of server designed to install, operate, and host applications. Now, in the early days of application servers, there was a huge growth in the number of applications being brought to the internet, right? Those applications became bigger and bigger with a demand for adding more and more functionality to the application and became more and more complex to run and maintain. So, obviously, this generated a need for some kind of program on the network to make sharing application capabilities efficient and organized. So, also, it's called an app server. An application server is a program on a computer that handles all application operations between users and an organization's back-end business applications or databases. So an application server is typically used for complex transaction-based applications. So in order to support high-end needs like heavy traffic and complex requests, an application server has to have built-in redundancy, monitor for high availability, high-performance distributed application services, as well as support for complex database access. So these applications come in all sizes, shapes, and use cases. In a world where we rely on a host of critical business processes, it's these application servers that are the high-powered computers providing application resources to users and web clients. So application servers, physically or virtually, sit between database servers storing application data and web servers communicating with clients. These app servers and their akin middleware are the operating systems supporting an application's development and delivery. Whether it's a desktop, mobile, or web app, application servers play a critical role in connecting a world of devices. So we're going to look at how application servers fit into a network's service architecture, how app servers support web servers, native applications, and mobile apps, as well as the current state of application servers in these 2020s. So as you may already know, an application server provides web pages or application content that is dynamic or allows complex user interactions. Dynamic content is more interactive and involved than static content, and it changes regularly due to end-user manipulation. With e-commerce fields, suggested items on internet shops which are dynamically repopulated based on end-user behavior and current promotions, real-time business intelligence and analytics, real-time user data such as location or weather information, back-end content management systems. Now, in contrast, static content generally doesn't change unless it's manually edited by the site owner, like a blog article, for example. Application servers use multiple protocols, including HTTP, the most common web protocol, and IIOP SSL, which increases the number of programs with which the servers can share business logic. Use multithreading, which adds speeds and efficiency to computing processes because multiple threads can run concurrently. Implement business logic, which manages rules for data behavior within software. So, check out the application server terminology in front of you. So we got this web server, right? That's responsible for storing, processing, and delivering data I/O for web pages. Web clients, which are the endpoints attempting to access the web or application resources. HTTPS, communication protocol between web server and web clients. We've also got servlet, JSON. This is the language for exchange between web and application servers. Business logic. These are basically rules for data storage and transfer of application resources. The application. It's a software program or website attached to a database. So as you might imagine, there are billions of web clients that make HTTP requests every day, every hour, every second, for goodness sake, expecting instant access to you name the app, whatever. So, Headspace during the morning routine, Google Docs for extensive reports, and Twitter maybe during a coffee break. No matter the application in use, it's being pulled from an application server and then delivered via a web server. So web servers are responsible for serving web clients' HTTP requests with HTTP responses. Unlike app servers, the web server design is light enough to process static data requests for multiple applications or websites while maintaining their security. Dynamic requests, often in the form of applications, require some additional assistance. So application servers work as an intermediary between databases, which store application data, and web clients. They also communicate with web servers, which deliver content to the web client. Application servers and web servers both communicate using servlets, which are server-side Java classes that process web server requests and return a response. Servlets are used to return dynamic web content to web pages. They process complex requests and transform data from the database. Servlets cost less than Common Gateway Interface, or CGI scripting, another server extension, and they directly connect to the server where CGI does not. For example, when a web user searches a web application in their browser, the user's request is sent through the web client to the web server, or web application server. The web server requests dynamic content from the application server, often using a servlet. The application server pulls data from the application database and returns it, along with any dynamic content, to the web server. The web server loads the web application for the web client and end user. This process differs slightly depending on whether the server is a joint web application server or not. But in web server architecture, reverse proxy servers and load balancers distribute traffic requests to the servers with available capacity and bandwidth. That way, user demands can be handled efficiently. Nobody will ever notice. So let's have a look at how application servers actually work. Now, they're basically used in web-based applications that have three-tier architectures. The position at which the application server fits is described like this. Tier 1 is the GUI interface, and that resides at the client end and is usually a thin client, for example, a browser. For Tier 2, this is called the middle tier, which consists of the application server. And for Tier 3, well, the third tier is most likely the back-end server, for example, a database server. So as you can see, they usually communicate with a web server for serving any request that is coming from clients. The client first makes a request, which goes to the web server. The web server then sends it to the middle tier, the application server, which then further gets the information from the third tier, which is the database server, and sends it back to the web server. The web server further sends back the required information to the client. But of course, there are different approaches being utilized to process requests through the web servers. And some of them are actually approaches like JSP, or Java Server Pages, CGI, ASP, Active Server Pages, JavaScript, Java Servlets, and the list goes on, especially as new ones are developed. Now, it certainly helps the clients to process any requests by connecting to the database and returning the information back to web servers. The main purpose of the application server is a mechanism for reducing the size and complexity of the client programs, for the need to cache and control the data flow for better performance. Also, a mechanism for implementing security for data as well as end-user traffic. Now, although they can have a different purpose, not all application servers are used for the same functionality set. For example, someone might need it for scalability. Others might need it for better managing of applications for the web. And that list will go on and on. Applications and web servers have complex and connected relationships. Generally speaking, though, web servers provide only static content and serve only HTTP requests. It's the application servers that handle dynamic content and business logic. In some server architectures, application servers sit behind web servers and provide all the dynamic content whenever it's requested, as the earlier graphic showed you. Web and application servers overlap, and in many web applications, both a web server and an application server must work together to deliver dynamic content on a web page. Large web applications with high traffic typically use multiple servers, at least one web server and one application server. So check out this beautiful graphic. So when it's designed to serve HTTP and other business logic requests, it's an application server. When it's designed to serve HTTP requests, that makes it a web server. If it stores and provides business logic, it's an application server. If it stores and provides static web content, well, that makes it a web server. If resource utilization is heavy, yeah, application server. If resource utilization is kind of light, that'll be better for a web server. If you need to support distributed transactions and enterprise Java Beans, or EJB, you're looking at an application server. But if you only needed to support servlets and Java Server Pages, JCP, and JSON, you're talking web server. So some of the advantages: providing a mechanism for dealing with all the components and running services like session management, synchronous and asynchronous client notifications. It becomes very easy to install applications all in one place. Changing to any configuration, such as moving the database server, can be done centrally from one location. Patches and security updates are easy to deploy through them. It certainly enables the ability to distribute requests to different servers based on their availability. Now, this is done via load balancing. It provides security to applications. It also enables fault tolerance with the ability to recover failover. It also saves big time if we are required to install a copy of configurations on each machine individually. It supports transactions. When it comes to performance, the application server greatly improves application performance because it's based on the client-server model. Now, of course, there would be a huge number of application servers in use today. I'll give you just a few examples right here: JBoss, WebLogic, WebSphere, Glassfish, TCAT Server, Apache Geronimo, JRun, Oracle OC4J. Those are just some of the ones that you may have heard of. But there's also Sun Glassfish Enterprise Server, SAP NetWeaver AS, Sybase Enterprise Application Server, and of course that list will go on. Some of the more popular application servers include Apache Tomcat. Now, this is an open source server for Java. Sun Microsystems first developed the code for Tomcat, but eventually gave it to the Apache Software Foundation. Tomcat is technically a web server. It doesn't have full application server capabilities, but it's considered an application by the industry because of its Java functions, such as servlets, and those actually allow it to power plenty of applications that only require Tomcat's Java features. Oracle WebLogic is a Java Enterprise Edition application server, and this is designed for enterprise applications. According to Oracle, WebLogic can run on Kubernetes, allowing app developers to build container applications. WebLogic runs on-premises applications and can also run on Oracle Cloud Infrastructure, OCI, for cloud applications. IBM WebSphere is a computer software that serves as a web application server. Now, WebSphere is a Java EE runtime environment. It's intended for enterprise applications, including those that plan to migrate to Kubernetes and containerize apps. Customers also use WebSphere to build applications as well as host them. WebSphere works alongside web servers like Apache HTTP server. Now, in order to choose the right one for your applications, you could start by identifying and prioritizing the requirements of your particular environment. A few of those factors would definitely include expected performance, administration, development, support, compliance, scalability, reliability, and cost. So once you're done with the task, you can then start looking for an application server that best meets your demands. For example, if you do have a large customer base, the application performance should probably be of topmost priority. And if your company is small, well, cost might be a factor as well. Scalability and administration would also be one of the major factors to look at if your application is going to be growing every day. Now, the application server market expects to continue to grow at a CAGR. Do you know what that is? Compound annual growth rate of 13.2%, rising from nearly $17 billion in 2020 to $41 billion by 2026. So continued growth is no surprise, though, as internet connectivity and reliance on applications continue to grow. Now, this migration to the cloud platforms and services and the boom of IoT devices are two key drivers in the modern application infrastructure and middleware market. Now, add all this to the movement toward BYOD, or bring your own disk policies, and remote workforces dependent on increased connectivity and operational efficiency. We're blowing the roof off, my friends. There's no mistaking the value assigned to these powerful modules and their role in serving clients with application resources. Oh, but hey, guess what? Don't be too disappointed. It's time to wrap it up. But you have learned a great deal about application servers. So stick around, queue up the next video. I'll see you then.